Today we're going to be working on Unit D, solving cubic equations. So in the previous lesson we did solve square equations. Our focus now is going to be on cubic equations. Our content objective is students will be able to solve cubic equations. Language objective is students will be able to explain verbally how to solve radical equations. Why am I learning this? Well, it's important for real-world problems like finding the side of a cube if you know the surface area. So first thing we're going to do is go over some background knowledge. We did go over a problem where they gave us the area of a square and we had to find the length of each side. So here we do know that the area is 289. The sides we don't know. We assigned it a variable. We find the area of in this case, a rectangular shape is just base times height. So here base is s, height is s. So we end up with s squared equals 289. We did learn from the previous lesson that the inverse of something squared is to take the square root. So if you take the square root of both sides, we did end up with that s equals 17. In this case, the side of each square is 17 feet. Now let's learn about something other than a square root. Now we're going to learn something called a cube root. A cube root is an operation that yields a number which, when multiplied by itself 3 times, it produces the given number. So here, let me give you an example. The cube root of 8 is 2. And why is it 2? Because 2 times 2 times 2 is 8, or in other words, 2 cubed equals 8. So let's go ahead and generate a list of some perfect cubes. That way we can kind of use it as a reference sheet, just like we did with the perfect square. So in order to make a perfect cube, you just take a number, cube it, and then that number, that's the result, is a perfect cube. So 0 cubed is 0. So 0 is a perfect cube. So if I take the cube root of 0, the answer is 0. 1 cubed is 1. So 1 is a perfect cube. Cube root of 1 is 1. 2 cubed is, like we see here, is 8. So 8 is a perfect cube. The cube root of 8 is 2. 3 cubed is 27, so the cube root of 27 is 3. 4 cubed is 64, so the cube root of 64 is 4. If you're wondering how I'm doing this, I'm just multiplying 4 times 4, which is 16. 16 times 4 is 64. 5 cubed is 125, so the cube root of 125 is 5. 6 cubed is 216, so the cube root of 216 is 6. So this is a really good list that you should have down to kind of reference. It's going to be quick and easy for you. The more you reference it, the more you're going to commit it to memory. So I highly suggest you write this down somewhere so that you can refer to it in the future as you're working out problems. Okay, so let's look at our very first word problem. It says, the volume of the cube below is 260 cubic yards. What is the length of a side of the cube? So for volume, what we do is first we find the area of the base, and then we multiply it by height. In this case, the area, first of all, let's consider the base, which is this right here. Since it's a cube, the base is a square. So we're basically going to do the area of the base times height. Now, real quick before I even move on, we do know the volume is 216, but we don't know the length. Okay, that's what they're actually asking us to figure out. So what I'm going to do is go ahead and understand that a cube is basically where all the dimensions are the same. I'm going to pick a variable. I think I'm going to go with the letter S. So I'm going to go ahead and say that all of the sides are S's. I went ahead and marked that the volume is 216. Now what I'm going to do is find the area of the base. So this highlighted area, which is a square, I'm going to go ahead and say S times S. That's the area of this base, but I have to multiply it by the height, which is another S. And this is going to equal 216. Well, S times S times S is S cubed. So if S cubed equals 216, what is S? In the same way, the square root is the inverse operation of something squared. The inverse of something cubed is the cube root. Now it looks almost identical to a square root symbol, except there is an extra number right here. We're going to put a 3 to indicate that it's a cube root. So whatever you do to one side, I will do to the other. It's kind of tight there. So now the cube root of x cubed is just s. Now all I need to do is figure out, okay, what times itself 3 times is going to give me 216. Hopefully if you look back at the previous slide, you see that the answer is 6. So in order to answer the question, what is the length of a side of the cube, I would say each side length of the cube is 6. And this, since it's given in yards, I'm going to go ahead and say yards. Okay, so again, if you keep this sheet in handy, you're going to be able to reference it really quickly. If not, you're going to have to guess and check, okay, what numbers to try and what not. Okay, so go ahead and now let's go ahead and take a look at the next example. Go ahead and pause the video and try this one on your own. Okay, so for this one, hopefully you identified the fact that the volume is 125. You went ahead and labeled a variable. It doesn't really matter which variable you choose. I chose S to represent side. You could have chose something else. So here, in order to find the volume of this cube, you're going to find the area of the base, which is a circle, so S times the height, which is S. So if s cubed equals 125, you're going to have to take the cube root of both sides. And here, the cube root of s cubed is just s. And the cube root of 125 is going to be 5. And let me just prove it to you real quick. 5 times 5 times 5. Here, 5 times 5 is 25 times yet another 5 will equal 125. So I'm going to say the length, let me just clean this up so it's neater. The length of each side is 5 yards. And that is your answer. So hopefully you got that one right. So now we're going to go ahead and move on to solving cubic equations. Our first example is x cubed equals 125. We're going to go ahead and do the inverse operation of cubing a number, which is going to take the cube root of both sides. The cube root of x cubed is just x, so I'm left with x equals the cube root of 125. So at this point, what I'm going to do is look for a number that if I multiply it by itself 3 times, it's going to give me 125. So if you haven't guessed already, the answer is 5. So now let's think, is there any other value that will create a true statement? Some of you might say, okay, well, what about -5? Would -5 work? Well, let's check. If I try -5 cubed, let's see what we would end up with. Okay, and we're just going to go ahead and write -5 3 times. A negative times a negative is a positive, so I'd end up with a positive 25 times a -5. A positive times a negative is a negative, so I would end up with a negative 125. Notice that is not the same as a positive 125, so -5 is not an option. So I'm going to go ahead and just check my work. If I take 5 cubed, does it give me 125? Yes, it does. So my only answer is actually a positive 5. It's not going to include both positives and negatives. Now here, what about this one? X cubed equals negative 125. So I'm going to go ahead and take the cube root just like before. And that's going to leave me with the cube root of x cubed is just x. So we have x equals cube root of negative 125. What number can I multiply it by itself 3 times to give me negative 125? The answer is -5. So again, some of you are going to say, well, doesn't positive 5 work as well? Well, here, if you look, we did 5 cubed, and we do end up with a positive number. So it's not possible to make it negative in this case. So my only answer would be a -5. And here, if I check my work, it would prove to be correct. So my answer is x equals -5. So something that you're going to see differently than the previous lesson is when you're taking the cube root of a number, there is only one answer. There isn't two. With the square root, when you're solving, there is 2, but when you're taking the cube root of a number, there is only 1. Okay, so now with that said, I want you to go ahead and pause the video and try numbers 3, 4, and 5 on your own. Okay, so let's check out our answers. Number 3, hopefully you took this cube root of both sides and you end up with W equals a positive 4. And no, it's not going to include any negative numbers. And of course, hopefully you checked your work and you said, okay, 4 cubed, does this equal 64? Yes, it does. So it does check out. Okay, number 4, hopefully you took the cube root of both sides and you end up with W equals a negative 3. Notice again, there's only one answer. So here, I'm going to go ahead and check my work. A negative 3 cubed, does this equal negative 27? Well, let me just show it to you real quick by writing it all out as an extended product. A negative times a negative is a positive. Positive times a negative is a negative 27. So this does work out. And then last but not least, this one, be very careful. You would actually have to take the square root of both sides because the inverse of squaring is square root. You can't take the square root of a negative number for now, so our answer is actually going to be no solution. And there's not really a way to check if it's no solution, so just want to make sure that before you claim it's no solution, make sure you're 100% positive that that is indeed the answer. Okay, so now moving on. What about something that looks like this? Okay, so I'm going to go ahead and, just like before, take the cube root of both sides. And here, what number can I multiply it by itself to give me a negative 216? If I have to multiply it by itself 3 times, I want to say that the answer is a negative 6. Now, let me just show you by checking my work real quick that it does indeed work. A negative 6 cubed, does this equal negative 216? Well, let me just write it out real quick. A negative times a negative is a positive. Remember, in the past we used to circle it like this. Positive 36 times a negative 6 does leave me with a negative 216, so it does check out. Okay, what about number 7? This one, just like before, we're going to always get rid of the constant first. So in this case, I'm going to add 5 to both sides, leaving me with x cubed equals 8. Not quite done yet. Take the cube root of both sides, and I end up with x equals 2. Let's just check our work real quick. 2 cubed minus 5, does it equal 3? Well, 2 cubed is 8. 8 minus 5, does this equal 3? The answer is yes. So it does work. Okay, now try number 8. So here, this means 5 times x cubed. So the inverse would be to divide both sides by 5. You'll see that the 5's cancel each other out, leaving me with x cubed equals. Here, I'm just going to do some side work. Negative 320 divided by 5. First of all, it is going to be a negative number. This is going to go in, that doesn't go in, 6 times. With 2 left over, 5 goes into 24 times, so that's a negative 64. So what you're going to have to do is take the cube root of both sides, and my answer is x equals negative 4. Now, real quick, let me just check my work. 5 times negative 4 cubed equals negative 320. Here, we're going to have to cube the negative 4. That's going to leave me with a negative. 4 times 4 is 16. 16 times 4 is 64. Now, does this work? Let me just show you real quick. 64 times 5, that's 20. 30 plus 2 is 32. So I do end up with negative 320 equals negative 320. Okay, so what about number 9? So here you can read it as w squared over 2 equals 32. However, a better way in this case might be to say w squared divided by 2. Why is that helpful? By understanding that it is division, I will be able to I'll be able to identify the fact that the inverse operation of dividing is multiplication. So I'm going to go ahead and multiply by 2, and then I will see that the 2's cancel out. Let's go ahead and do side work. 32 times 2, that's going to be 64. So I'm left with w squared equals 64. Now be very careful. This does say w squared. So I'm going to have to take the inverse, which is the square root. So please don't get into the habit of taking the cube root of everything. Make sure you're looking at the numbers carefully. So here I'm going to say w equals plus or minus the square root of 64, which is w equals plus or minus 8. So the one thing you have to be very careful about is making sure you distinguish from w squared and w cubed. Some of you might get too caught up into one form of answer that you start answering like that every time, even though it's not applicable. Real quick, let's check our work. We have 8 squared over 2 equals 32. 64 over 2 equals 32. Is this true? Yes, it is. Now notice here when it's squared, even though there is 2 answers, you don't really have to check both. Checking one is going to be sufficient because 8 squared is 64 and negative 8 squared is also 64. So there's not really a point to checking both. Okay, how about number 10? Just like before, I would read this as x cubed divided by 9. Why? Because by recognizing that it is dividing by 9, I can identify that the inverse would be to multiply by 9. That's going to leave me with x cubed equals negative 27. Simply take the cube root of both sides, and I would end up with x equals the cube root of a negative 27, which is x equals negative 3. Yet again, when we're taking the cube root of a number, you're going to find that we only have one answer. Here, let me prove to you that this is the only answer that works. A negative 3 cubed over 9 equals negative 3. Let's see, negative 3 cubed is a negative 27. Negative 27 divided by 9 equals negative 3. Is this true? Yes, it is. Now, if you weren't sure, you're like, wait, Miss Singh, doesn't 3 work as well? Try it out. 3 cubed, so just let me show you in a different color. 3 cubed divided by 9 does equal negative 3. Well, whoops, cubed. 3 cubed is 27. 27 divided by 9, does that equal negative 3? No. So that's further proof that only one of the signs will work when you're taking the cube root of a number. Now at this point, what I'd like you to do is go ahead and pause the video and try the next few problems on your own. Okay, so let's see how well we did. Hopefully for number 11, you do recognize it's squared, so hopefully you saw that the answer is actually plus or minus 9. Okay, number 12, the answer is just n equals negative 6. So again, we're taking the cube root of a number, there's only one answer. Number 13, the answer is no solution. You'd be taking the square root of a negative 6. And for now, we can't take the square root of negative numbers. Number 14, the answer is 4. Okay, so yet again, whenever you when you end up taking the cube root of a number, you should only have one type. When you take the square root of an answer, you will generally either have 2 solutions or no solution at all. Okay, so let's move on. Now, it's going to get a little bit more complex, but nothing's going to change. Same idea. We're going to first get rid of the constant by, in this case, subtracting 34 from both sides. Now you have to be very careful to make sure you have the correct sign. Here I will be left with 2x cubed equals negative 16. A lot of students are going to forget about the signs, and then it's going to jeopardize their entire answer. So be very careful that you make sure is your sign positive or negative. Now we're going to go ahead and divide both sides by 2 because 2x cubed basically means 2 times x cubed. That's going to leave me with x cubed equals a negative 8. Be careful and make sure you have the sign correct. So here, almost there, we're going to take the cube root of both sides. And let's show it here. We're going to make sure I use that 3 to identify that it is a cube root. Okay. So here, the cube root of -8, my answer is going to be -2. Now, real quick, let's just go ahead and check our work. 2 times a -2 cubed plus 34, does that equal 18? Well, let's see. We have 2 times -8 plus 34 equals 18. Here we're going to get a -16 plus 34. Does this equal 18? The answer is yes. So we're good to go. Okay, so let's try another example here. Now it says x cubed over 4 minus 23 equals 31. Same thing as before, we're going to get rid of our constant first, so we're going to add 23 to both sides. We're going to be left with x cubed over 4 equals 54. Now here, since they're both positives, you usually won't make an error there. Now here it says x cubed over 4. A better way to read it might be x cubed divided by 4. Why? Because then that tells me, okay, I'm going to have to do the inverse. The inverse of dividing by 4 is to multiply by 4. That's going to leave me with x cubed equals 216. So if I take the cube root of both sides, I'm going to end up with x equals 6. Okay, real quick, let's check. We have 6 cubed over 4 minus 23 equals 31. 6 cubed is 216. 216 divided by 4 minus 23 equals 31. 216 divided by 4, let's just check that out real quick. 216 divided by 4, that does not go in. This goes in 5 times. 1 left over. 4 goes into 16 4 times. So I'm left with 54 minus 23 equals 31. Is this true? Yes, it is. So it works for number 16 as well. Now it's your turn. So go ahead and pause the video and try number 17 through 20 on your own. Okay, let's check out our answers. Hopefully you were very careful with taking the cube root or the square root. So here, number 17, the answer is C equals -2. Number 18 is no solution. Number 19, x equals 4. And number 20 is n equals plus or minus 5. Okay, so now we're going to go ahead and move on to word problems, your favorites. It says here, the volume of a sphere below is 288 pi cubic meters. What is the length of the radius of the sphere? So first thing that you're going to have to know and commit to memory is the volume of a sphere, which is, excuse me, volume equals 4/3 pi r cubed. Now that I know that, what I'm going to do is plug in what I do know. The information that they gave us is the fact that the volume is 288 pi. So what I'm going to do is go ahead and replace V, which stood for volume, with 288 pi, which leaves me with 288 pi equals 4/3 pi r cubed. Now, the first step to solving for r would probably be for me to get rid of this fraction. And yes, a lot of you would read this as 4/3, but a better way in this case might be to read it as 4 divided by 3, because then I can see in order to get rid of divided by 3, I'm going to have to do the inverse, which is to multiply by 3. So I'm going to do that to both sides. Here you're going to see if I put this over 1, the 3's will cancel each other out, which will leave me with 864 pi equals 4 pi r cubed. If you're wondering how I got 864, that's basically me multiplying 288 by 3. Now what I'm going to do is go ahead and get rid of pi. So I'm going to go ahead and divide both sides by pi. You'll see that the pi's cancel each other out, which leaves me with 864 equals 4r cubed. Now what I'm going to do is, since I understand that 4r cubed means 4 times r cubed, I'm going to divide both sides by 4, which leaves me with 216 equals r cubed. We're almost done. We're going to go ahead and just take the cube root of both sides, and I'm left with r equals 6. So to answer the question, what is the length of the radius? I'm going to say the radius is 6, and don't forget the units. It's in meters, so I'm going to say 6 meters. This type of answer will suffice as well, but sentences definitely help you understand what you're trying to do in the first place. So I'm just going to show you one more. Actually, I'm going to go ahead and have you try the next example on your own. So go ahead and pause and see how well you do. Okay, so here, let's go ahead and first understand the information we're given. We're given a volume, which is 972. For the sphere, the next thing we're going to have to do is write down the formula, which is V equals 4/3 pi r cubed. I'm going to go ahead and replace the volume with the number that was given to us. So I'm going to go ahead and put 972 pi equals 4/3 pi r cubed. Again, we want to get rid of the 3 first, so let's multiply both sides by 3. You'll see here that the 3's cancel each other out, leaving me with 2,916 pi equals 4 pi r cubed. I'm going to go ahead and get rid of pi first by dividing both sides by pi, leaving me with 2,916 equals 4 r cubed. Now we're going to go ahead and get rid of the coefficient. This means 4 times r cubed. So the inverse would be to divide by 4 to both sides, leaving me with 729 equals r cubed. Now what I'm going to do is take the cube root of both sides. And the cube root of 729, you probably don't know off the top of your head yet, but the answer is 9. So to answer the question, what is the length of the radius of the sphere? I would say the radius is 9 meters. And I can't stress enough, make sure you write your units. Okay, moving on to the last example. Now the last example is very similar to the other two, but this here is going to intimidate you a little bit because the volume presented to you is expressed as a fraction. This should not deter you. None of the steps are going to be different, really. So here, let me show you. I'm going to start with the formula just like before. Volume equals 4/3 pi r cubed. Now what I'm going to do is, just like before, replace volume with what was given. So for volume, I'm going to go ahead and plug in 32 pi over 3 equals, and then 4/3 pi r cubed. Just like before, I wanted to get rid of my fraction, so what I did was multiply by 3. Because this is 4 divided by 3, so if you multiply both sides by 3, oh look, the 3's cancel out on the left side, and so do the ones on the right side, which makes it easy because now I'm just left with 32 pi equals 4 pi r cubed. Now what you're going to do is go ahead and get rid of pi by dividing both sides by pi, leaving me with 32 equals 4 r cubed. This means 4 times r cubed, so the inverse would be to divide by 4, leaving me with 8 equals r cubed. Here the line was a little off, it should be crossing out the 4th, not the r. So take the cube root of both sides and I'm left with r equals 2. So I would say the radius is 2 meters. And there is your answer. So that is actually going to conclude the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.